So this Unit 5 quiz is a real reality check on how well your study methods are producing lasting understanding. Two, if you actually understand how concepts connect. And three, how your brain works. Does it work in a sequential form? Are you someone that can do four different things with one type of problem? Or are you someone that needs to do like just balancing and then go back, just identifying and then go back? Like maybe you're not someone that can merge all of the skills at once. You have to teach yourself in chunking of the skills. First, let me get really good at balancing. First, let me get really good at identifying. First, let me get really good at writing ionic compounds and then try to put it all together. Like maybe you need to approach study like that instead of trying to do it all in one round. Like, I don't know, but like that's where talking to me really helps because I can offer you those slight adjustments that actually you still get all the material in, you still get the final skill in, you just approach learning that skill differently. Okay. Um, but this is a really big reality check for a lot of you guys on your actual knowledge, understanding, and on your methods of study. Right now, it looks like you guys have been doing okay because term A, the first term of this, was actually easy. Like it's hard because you don't know it, but in terms of where you're headed, that was the easy stuff. You're now getting into the cumulative harder stuff. Okay. And so all of those areas that you maybe glossed over last term that you kind of managed to get by are now coming out to the surface and be like, oh no, that's an actual hole that I need to fix. Okay. So keep that in mind. The other thing I want to say though, on kind of contradicting what I just said, is that you also know more than you think you know in a small sense. So, like, for example, yesterday, period two, lots of kids were struggling way more, even more than you guys. And I just started saying, okay, stop trying to answer the question. Tell me literally anything you know. So what I had them do was I started telling people, you're going to get the zero on this. Like that's obvious. But maybe what you can do is at least tell me what you do know. I know that an ionic compound is a metal plus a non-metal. I know that it has a charge. I know that copper is a transition metal. I know that this means charge. This is a Roman numeral number 2. Like I just started having them list anything that they did know on paper to also say that you know more than you think you know. The problem is you don't know how to put it together. But don't forget that part too. Like you are underestimating your skills of probably synchronizing everything together, but I think you're all or maybe I should put it this way, you're overestimating your skills of synchronizing it together, but you're underestimating your skills of how much small things you do know. You just need to figure out how to web them, okay? How to connect them. So whenever you have quizzes like this, the best thing you can do is not leave things blank, but it's to start writing anything that you do know. Start turning it into a study tool. Just start saying, well, what can I say? Anything about this on the page. Forget answering the question. Just look at anything and say calcium. Oh, I know it's a metal and it's column 2. So I know that it's going to have a 2 plus charge or it has 2 valence electrons. Like literally just write anything that you know. Okay. It's a metal, right? So I know that metal is always going to take on a positive charge. Like start laying out the information for yourself and you might find that the connections start to become clear. But if you try to make these connections in your head without a visual, most of your brains do not work that way. Like I can almost guarantee you, none of your brains successfully work that way, especially in this class. There's way too much to connect. There's way too much information floating around. You cannot use your old methods that you use for the humanities, which is reading. Reading methods do not work in this class beyond reading the prompt. Your ability to read an essay and write some bullcrap statement about how you think it affects this and argue your way through an emotional statement does not work for this class. You need to have the right answer, which means you need to understand the right concepts, which means you need to build the correct connections. And if you are not putting in extra time at home, you are not going to pass this class. And I can't help you if you never ask me, if you never tell me how you study, if you leave, if you plan days where you're gone, if you plan appointments. Tell your parents stop making appointments during this class. It is too hard of a class to make up. And you know that it stacks fast, right? So there is this catch 22 of you know more than you think you know, but you need to prove it to yourself by putting in the extra time so that when you make those connections and I ask you to apply your knowledge, you're successful in your application. You're not just winging it. Okay? Because I clearly, based on these scores, y'all winged it. And it didn't work. Okay? So what I want to do is I want to go through another round of this quiz with new chemicals. But I modeled it just after the quiz, the same type of reactions. And we're going to walk through this together. Okay? And if you got a good score, awesome. This is just another round of review for you. You will benefit from it no matter what. Okay? So does everyone have a scratch paper out or Notability? Okay, perfect. So what we have is I have problem 1 out of the 3 reactions. I have a reaction between the following 2 ionic compounds occurs when copper 2 sulfate and calcium iodide, okay, are mixed. So immediately what you should notice that copper 2 sulfate, I might just write out the reactants just immediately. So I know copper is Cu. I know that 2 plus, that 2 Roman numeral is telling me that this transition metal has a 2 plus charge. Metals can only have positive charges. Metals only lose electrons. They only lose negativity, which means they only become positive. And then I see that it's a metal plus a polyatomic. Okay. How did I know that this was a polyatomic? Bryce, how did I know that this was a polyatomic? Because I cannot find any chemical, any element on the table called sulfate. Okay, so this is a polyatomic. And by the way, if it's a polyatomic, that means it's an ion that carries a charge. So I know automatically, 1, I put it in the prompt, it's 2 ionic compounds, but I also could put it together that's an ionic compound. It's a metal plus a polyatomic. Okay, it's 2 charged things bonded. So then what I get is I know sulfate's gonna have a 2 minus charge. So I see that if copper has a 2 plus and sulfate has a 2 minus, then I need 1 of each group. 1 copper and 1 sulfate. So I get CuSO4. And you would have to memorize what sulfate is. That is your sulfate group. And then I get it's mixed with calcium iodide. Well, I know calcium is Ca, and calcium carries a 2 plus charge because it's column 2. It's in column 2. Okay, this is calcium, which means it's going to lose 2 of its valence electrons to become like the noble gas behind it, argon. So that means it's going to carry an overall more positive charge because I lost 2 negatives. Okay, so I get calcium 2 plus and iodide, okay, is a halogen. Iodide is iodine bonded. I'd like to make a bond with you, right? So iodine is going to gain 1 electron to become like xenon. So what we say then is iodine is going to take on a 1 minus. So what does my formula become for an ionic compound? Calcium I2. Because I need 2 iodines to cancel out my calcium 2 positive. So what is the type of reaction? 2 ionic compounds. What does this fall under? Double displacement. Excellent. Somebody wrote double dissociation. You don't know if it's dissociation until you figure out what the products are. You cannot know that. Double displacement. So under double displacement are 2 categories, fancy dissociation or a solid made. You don't know which version of double displacement that is until you figure out your products. That's under the umbrella of double displacement. It's all under the umbrella. You got to figure out your products before you know if it's just a fancy dissociation double displacement or if you're actually getting a chemical reaction making a solid. Okay. So that's the 2 routes of double displacement reaction. That's the 2 types of results you can have. So now what we do is we're going to balance with the correct states of matter. So I'm going to write my reactants, copper, sulfate, and what's the default setting for states of matter for an ionic compound? Aqueous, because if you think about the solubility lab, you drop liquid together. How do you make that liquid? You dumped a bunch of solid copper sulfate and you mixed it with water. That's how you got the little liquid samples. So it's aqueous. Could I ever start, at least in double displacement reactions, would it make sense for me to start with a solid? No, because how would I know then if I created a solid, if it already looks like a solid in the beginning, right? Plus calcium iodide, aqueous. Okay, now that I know that my type of reaction, I'm color coding. So based off of type, green, I now can predict my products. So I'm going to switch my cations because that's how I like to think about it. I like to switch the positives out for each other. So I make it now copper iodide and calcium sulfate. But what do I need to check for? If I make new ionic compounds, I need to check for what, Mika? Charge. So I need to make sure that I make good new ionic compounds, not just any old mixture, but that they actually follow the rules of ionic compounds, that they add up to 0 in the charge, they cancel out. So copper has a 2+ charge, iodine has a 1-. How many iodines do we need? 2. Okay, calcium has a 2+ charge. Sulfate has a 2-. Do we need to add any subscripts? No. Okay, so we're done there. So now I have to balance this thing. Well, we could go either way. We could do states of matter first or balancing. Doesn't matter. Let's do actually states of matter. Okay, so what do I need to use? I need to use my table. So my table tells me, okay, how do I know if this is a fancy dissociation or a solid? I look at my table. Okay, rule that it talks about copper and iodine. The first rule where I see anything mentioned about iodine is this rule, rule number 5. And it says that iodine is soluble with almost every single cation, every single positive carrying thing, except for silver, lead, and mercury. Is copper, silver, lead, or mercury? No. So then what is the state of matter? Aqueous. So that means it dissociates. Aqueous. Okay, that's rule number 5 in my table. I look at calcium sulfate. Okay, the first place I see sulfate is here, and it even talks about calcium with a 2+ charge. Based on rule number 6, what is my state of matter for calcium sulfate? Solid. So where's the actual chemical reaction? It's making the calcium sulfate. That's the real chemical reaction. That's the old bonds breaking, new lasting bonds forming. That's the actual new substance. That's the cloudy thing that comes out of solution that you're like, ew, that wasn't there before. Okay. So now you have to balance. Okay. Now balancing should be pretty easy at this point. So I start with 1 copper, 1 sulfate, and they're bonded together. So I'm going to make a little bracket to remind myself, whatever I do to one, I have to do to the other. Calcium, 1, iodine, 2. Okay, copper, 1, iodine, 2, bonded. Calcium, 1, sulfate, 1. And notice, I treat sulfate SO4 as one entire unit. Do I need to balance anything? No, it's already balanced. Oh my God, that's so wonderful. So you're done. Okay. Next round. Okay. Now remember, in the prompt of the quiz, it said I created a solid and a gas. Automatically, after doing this work, is this the one? No. You can just look at this and be like, this is not a solid or odorless gas. So this is not it. Okay. Okay. So now we go on to the next type of reaction. This was a mimic of your quiz. Okay. You go on to the next type and you say, okay, I have a reaction between liquid hydrocarbon C3H8 and pure oxygen. Okay. So automatically you should be thinking to yourself, okay, first of all, liquid means this is the state of matter. If I tell you it's a liquid, please write that it's a liquid. Okay. And pure oxygen. Oh, pure oxygen is O2. It's a diatomic. It's one of those Brinkelhoffs, which means it's a gas. How do I know it's a gas? Bro, you breathe it in every day. That's how you know. Okay. Sometimes like you guys are funny, like, even AP kids ask me a question like, how do I know that salt water is clear? And I'm like, the ocean? The ocean? And they're like, oh, it's like, how do I know sugar water is clear? I'm like, amazing. Okay, so you have your diatomic. Now, if you were someone that got stuck on this problem, what would I ask you to write? Maybe you couldn't get this. What you should have done is done anything that you do know. You should have written diatomic oxygen, gas. You should have written, oh, I think it reminds me of, speaking of diatomics, I think it reminds me of Brinkelhoff, right? Like, this is what I mean by if you get stuck, don't leave anything blank on the page. Just start telling me anything that you know about that little cue card. Okay. It's like if I just threw a word at you and I'm like, tell me anything about this. Okay. Start doing that. Don't leave anything blank. Okay. So I've got C3H8 immediately. I think in the problem, I even said this was a hydrocarbon. A C and an H. So what type of reaction is this? Combustion. Combustion. Okay. And there's something I know about combustion. It always produces three things. CO2, H2O, and heat. And specifically CO2 gas and H2O gas. How do I know that water is a gas here? Well, it's just partly memorization. It's also, if you think about the word combustion, we always think, oh, something catches on fire. Usually it's gas in the air, right? Gas. Yes.
Will you get graded down if you know that change? Sorry.
Heat, no. You won't get graded down for this. Okay. So then what we're doing is now we're going to balance with our chemical we're going to balance our chemical reaction and write the whole thing, the whole shindig. So I'm going to start with my reactants. So I gave you the compound C3H8. Like I didn't even ask you to write it. Like, and know what's amazing? Some people still translated it wrong. And I put it in the prompt. So I don't know if half of you need to go back to third grade to understand letters, or if half of you, maybe not half, but like 20% of you need to not read so fast. So basically, you're not reading anymore, or you need to calm your brain down and be like, it's on the paper, like, trust the paper. Okay. Because a lot of you guys, like, brains freak out and like nothing makes sense anymore. You got to teach your neurons to calm down. Be like, no, I am a logical creature. I am literally evolved to identify patterns, especially visually. Trust my evolution. Trust your brain chemistry. Okay. And then, of course, you should write liquid because I even told you it was a liquid. And then oxygen gas. Now we get into, okay, the product based on your identification of what type. So then it becomes CO2 gas and water gas. Okay, that was supposed to be the easy one because you should have noticed that it was combustion, so you didn't even have to get creative with the products. Like nothing about that asked your creativity. Like not a single ounce of it was asking you to be individual or create anything on your own. Like it was all there for you, like all of it. So then what we do is balance. Like that maybe was the hardest part. So this was a tricky one. This was a tricky balancing. This is where it got hard. So you have 3 hydrogens and 8 oxygens. Or sorry, 3 carbons and 8 hydrogens. And then you have 2 oxygens. You end with 1 carbon attached to 2 oxygens and 1 oxygen attached to 2 hydrogens. So then what you did is you should have gone through and you should have balanced and you should have gotten some weird numbers, okay? You should have gotten, if I multiply by 3 to balance out the carbons, I get 3 and 6, giving me a total of 7 oxygens. Okay, that's weird. I'm going to deal with my hydrogens, okay? I'm going to multiply this side product hydrogen by 4 to get me 8. But then if I multiply my oxygens by 4, it gets me 4. And so then I get that. And what I need to do then is I need to recognize that I have a total of 10 oxygens. So to get 10 oxygens on the reactant side, I'm going to multiply by 5. Now, your guys' quiz had a weird one where you multiplied by like 17 halves, and then you had to multiply all the coefficients by 2. So you got some big numbers. You got like 10, 12, 17, and 2. Okay. But even if you forgot to multiply by a half and you could show me that you got the right ratio, that's really good. Like I still wouldn't have given you the point. You still would have gotten docked off half because you didn't multiply by the times 2 to get out of that fraction because you can't have half a molecule. But like if you got the right ratio, that still would have gotten you at least half the point, right? So then what you do is you take your multiples and they become your coefficients. Oh God. So it becomes 1. I'm not going to write that. That's dumb. 5. Okay, hold on. Hello. 5. Okay, 3 and 4. Okay, based off of the prompt, my unknown reaction produces a solid and a gas. Is this your reaction? Is this the right one? No, because it doesn't produce a solid and a gas. You have to have both. These are 2 gases, not the reaction. Not it. Okay. A lot of you guys talked to me about like, first of all, it was so funny in your CERs. A lot of you guys wrote like, oh, it has to be this reaction because it produces a solid and a gas. I'm like, bro, you didn't even write that in your chemical reaction. So how would you know what it is? You couldn't even identify the states of matter. So how are you explaining to me that this is true because you told me something that you didn't identify? The other thing that you guys did is you'd get the right reaction and you wouldn't have any answer for it. So that makes me think lots of people cheated because they would write reaction like 2 or whatever. And then they would say, and I look at the reaction 2 and it's not even a reaction. Like they didn't finish the problem. And I was like, odd. How bizarre. A little sus. Okay. So I don't know if you guys are just really good at guessing or you all winged it cohesively quite well together. But if there's no work and you tell me something that isn't there, what? Conservation of knowledge, y'all. What's there before is there after. Like, I don't know what you guys are talking about. Okay, so last one. All right, last one. Reaction between solid mercury and aqueous hydrogen fluoride yields, which I wrote on the board means produce. So yield means produce. Mercury 2 fluoride and pure hydrogen. I gave you the products and the reactants. All you had to do was translate it to a formula. Like I gave the entire thing to you. Okay. And I'm sorry if I'm sounding a little frustrated, but it's frustrating because you're not dumb. But it's frustrating because you guys have all this knowledge in your head and you aren't utilizing me to help you piece it together. That's what's frustrating is you aren't dumb. You know this stuff. You really do. And if you don't, you definitely have the capability to. Okay. So, what is the reaction type? I have plain free metal, unbonded mercury plus aqueous hydrogen fluoride, which is ionic compound. What type of reaction is this? Single displacement or replacement. Both are okay. Single displacement or replacement. Both are okay. Specifically, it's metal. It's a metal kicking out hydrogen. Now, how do I know it's metal kicking out hydrogen? Well, I literally told you in the prompt that it becomes metal fluoride. So I literally tell you in the prompt that metal becomes the now new bonded atom and hydrogen breaks away. So There's that. Okay. And then what we do is we're going to create, if it's a single displacement reaction, we create a new compound, which I even wrote for you. So it becomes mercury. If I am a metal and I'm a loner metal, I'm not bonded. What's the state of matter? Solid. And look, guys, I even wrote solid. And still, like half the people forgot to write that it was a solid. And I wrote to include states of matter. Like, ooh, okay. Plus, what was the other thing? Hydrogen chloride. Okay. And I wrote that it was what state of matter? Which makes sense because it's an ionic compound. The default setting is unless the table says otherwise. But the table tells me anytime I have chlorine bonded with almost every single cation ion except for silver, lead, and mercury, I am aqueous. So if I'm bonded with hydrogen, I'm aqueous. It all follows the rules. Okay. So I have aqueous hydrogen chloride. Now, how did I know that it's those ratios of atoms? Hydrogen takes on a 1 plus charge, chlorine takes on a 1 minus. Then what I say is, okay, I know I'm going to switch cations. I also tell you it. So mercury now is connected. Wow, did I write chlorine? I meant fluoride. Sorry. Mercury, okay, is Hg. How did I know that? I put it in the prompt. Like I wrote on the board and in the prompt the symbol for lead. And a lot of you still wrote something different. Like it was wild. It was absolutely wild to me. I was like, what are you reading? Okay, so mercury is Hg. I just am copying the format of the quiz right now. Hg. And it combines with fluoride. Now, I need to check something. What do I need to check for? Charge. So I know that mercury, what's the charge of mercury? 2. How did I know that? Where did I give it to you? In the prompt, where in the prompt? What physical part of the prompt tells you the charge? What the Roman numerals, bro? Yes, you're all right. You are all right. It is in the prompt. It is in the word problem. It's in the second half. It's the Roman numerals. That is not the number of atoms. Stop calling it the number of atoms. I have literally never said it's the number of atoms. I say it's the charge because it's a transition metal. You guys know this. Stop telling yourself you don't. You do know this stuff. I have repeated it 1,000 times. Transition metals need you to be told what the charge is because they can have many different charges. So it has a charge of 2 plus. Fluorine has a charge of 1 minus. What does this compound actually look like? 2 Fs. Okay. And then I tell you pure hydrogen. I just say it. So it becomes hydrogen. Is it just plain hydrogen? No, it's a diatomic, it's Brinkelhoff. Okay, so it's H2. Automatically, what's the state of matter of pure hydrogen? Gas. Okay. Now, what are we missing? The state of matter for what? The ionic compound. Now, I recognize that I will add in for future classes the solubility table on the second page, but you also had the solubility table. You could have just flipped backwards. Like you could have just turned back the page. Okay. Like this is not how tests work. Most in tests in college, they just expect you to be smart enough to look at the resources you have and reference back to it. They don't put every single resource for every single problem. Okay. So like there is an element of this is where if you're someone who likes to take shortcuts, get smart about how to use the resources available to you. Okay. It's like during the midterm when I say sometimes if you skip a question, you might find that the question's answered later through another question to help you. Like look at the entire packet. You might be surprised that there's something there to help you. Okay. So when I look at this, halogens, that includes F is a halogen, is soluble with all cations except for mercury. So what, according to rule number 5, what is the state of matter for this? Solid. What do I have? A solid and a gas. So then, this is it. We did it. We found it. Los Hicimos. We did it. We discovered it. Oh my goodness. Okay, so now the last part was write the darn CER. Okay. Now, your evidence was all this work. All this work was your evidence. Okay, was the evidence. So really, you kind of just had to explain it. And I even told you before the test that your scientific principle is you should mention how you found it by saying you had to identify the type of reaction to predict the products. Ugh. All of you wrote either nothing or didn't make any sense. Like I literally wrote on some of your CRs, I was like, what? Like, did you read this? Okay. But with the ones that like actually created somewhat of a logical explanation, you wrote all about the products that you found and you didn't tell me at all how you knew those are correct. How'd you do that? Because I identified this reaction to be this, so it created this. I identified this reaction to be this, so it created this. And I identified this reaction to be this, so it created this. Like more than half of you didn't even mention the type of reaction. You just said, I found these are the products. It's like, yes, but how? How did you do that? Because if you don't know how you did it, you're not going to understand why this works. Okay. So it is, if I were writing this, okay, I would write CER, the unknown reaction was reaction 3 because I was able to identify it as a single displacement which produces solid HGF2 and hydrogen gas. And then I might talk about what did the other reactions do? Because, right, it's like, okay, well, what if there was another reaction that created that? Then I would talk about reaction 2 was a combustion, which creates, I'm going to start to get sloppy here because I don't want to write this whole thing. H2O. Gas. Okay. Reaction 1 was double displacement. Okay, DD, double displacement, because I'm lazy right now. Okay, which created blah, blah, blah. Like, the other thing that was really interesting is you guys didn't even mention, like, you did all of that work on evidence and you didn't even, like, write the actual products in your answer. It's like if I did all this work researching and I never even mentioned the molecule I created in my report. Like, yeah, so I created this thing. It was crazy. We got like 87% yield. Wild. This is how we made it. Okay, bye. And they're like, you did all that work and you didn't even tell me about your structure. You didn't even tell me about the compound you actually made. You just said, I made this. And it was white powdery thing, which most things are when we make things. Okay. Like, you did all that work. Why didn't you even mention the product name? Like, okay, so I'm not that frustrated at necessarily like you as an individual. I'm just more frustrated at why, what was so crazy? Like, other than all of the elements put together, like, what was so wild about this quiz that, like, what's stopping you guys from putting the connections together? Because I don't know how to help you. And I obviously am willing, like I'm begging you guys to tell me how I can make this class more understandable within reason. Like there's just a point where it's just chemistry, okay? There's just a point. But like even the students that do well in this class, even the students that are pouring in hours extra in this class, and you know who you are struggling. This was a really hard quiz and I want to help you just as much as I want to help the students that are really, really struggling. Like everyone, I want to help everyone. So is there something I can do that, or something I need to know that is within reason for me to modify or understand about how your brain works? Like what was stopping you guys from putting this together? Okay, so we have said one student said that the paragraph in the beginning, it's too much. Okay, trick number one, you guys are also doing your CAS testing, juniors, okay? CAS testing, state testing is coming up. Here's a trick of the trade. And by the way, if you're an AP student, you also should know this, especially if you're an AP math or other science student. You often get long but prompts, way too much information. What do you look for? Look for the part that tells you in a prompt or background. Okay, read the question or task first. So this gives you direction on how to do it. So like if you're like super overwhelmed by the background, just read the last two sentences of the background where you typically are told what the goal is. Forget the rest of it. If you need the rest of it, you'll be pushed back there. If you start running out of things, that's when you go back to the prompt. You're like, oh, I feel like I'm missing something. Then go check the prompt. But this is a really good test taking skill. If you're super overwhelmed by the beginning paragraph, just find the part of the paragraph, which is usually at the end or in bold, like I did, that tells you your task. And then only when you start figuring out while you're taking the test or while you're taking the question that you're missing something, then go back to the prompt. That's probably where that information was. Okay. What else? What's another thing that I can do to help either give you a skill or understand better? So practice sheets, really, really good. I totally agree with you. I think I did, but the only thing I didn't do is I didn't write out the names first. So maybe that was my mistake. So what I gave you guys was in the slide deck and on Friday, the weekend before this test, I had given you guys this practice quiz. Practice quiz is similar. Key to practice. Okay. But what I didn't do is I didn't write it out as word problems first. I just isolated the idea of predicting, type, and balancing. But I didn't give you a full, okay? So I can make a modification and start writing some of those in word form so that you aren't thrown off from the get-go. Totally fair. Totally fair. Okay, what else can I understand or do to help avoid a test quiz like this from happening again? Okay, so what we're going to do right now is you guys are going to correct your quizzes, having gone through a second walkthrough with me. And then we're going to move on tomorrow to how do we quantify the math of chemical reactions. All right, for those of you at home, you're going to want to find a time to retake this quiz do corrections and talk with me. You guys really should prioritize while it's still the early start of term B. For this class, you should prioritize meeting with me if you're having troubles creating effective study methods. All right, guys, good job.